Hi, today's lesson is on algebraic expressions. The simplest possible algebraic expression is just a number, like say 3 or 31.2. These are algebraic expressions. Of course, there's more to algebraic expressions. They usually involve a variable, say x. So a typical algebraic expression would be something like x plus 3 or 2x minus 4, or maybe x squared minus 3x plus 7. Let's see what these mean. So let's see what we mean by a variable first. So variable is a letter which is supposed to denote a number. We don't have the value of the number, but we know one thing for sure. It is a number. So whatever we do with this variable, it must follow the rules that numbers follow. So you can add to a variable, you can multiply to a variable, you can divide variables, and you can raise variables to powers, just like you can do with numbers. And whatever you do must be consistent with the laws of numbers. So the operations that we use on numbers just extend to the operations on variables. So let's see what these three expressions actually mean. So x plus 3 means that x is a variable which is some unknown number, and then I've added 3 to that unknown number, and I've got a new unknown number which I denote by x plus 3. I don't know x, so I don't know x plus 3. But I do know that x plus 3 is 3 more than x because I've added 3 to it. And there's no way to calculate this value unless I know x. So when I know x, I will know x plus 3 by adding 3 to that value of x. Until then, the only thing I can do is express it as x plus 3. I can't simplify it further. Similarly, what about this expression? So it's made up of two parts. It's made up of 2x and it's made up of a minus 4. Let's understand the 2x first. 2x is just short form notation for 2 times x. We don't want to write the times symbol every time, so we just drop it. We write 2x. So 2x just means I have a number x and I've doubled it. I've multiplied it by 2. Or I've added it to itself. 2x is also the same as x plus x. Because when you add something to itself, it's the same as multiplying by 2. And then what have I done to this expression? So I've found out 2x and then I've subtracted 4 from the expression. So 2x minus 4 is actually 2 steps. I have some unknown x, I've doubled it to get 2x, and then I've subtracted 4 from it to get 2x minus 4. Since I don't know x, I can't actually perform these operations and give you an answer. The best I can do is write it as 2x minus 4. Once I know x, I will perform the operations of multiplication and subtraction and end up with an answer. As it stands, 2x minus 4 is the best way to express this number. So similarly, x squared minus 3x plus 7. I have some number x, I square it. That means I multiply x with itself. That's x squared. Then I subtract 3x from it. That means I multiply the number by 3 and then I subtract it from its square. And then finally I add 7 to it. So this expression is having an unknown number x, squaring it, subtracting 3 times the number from the square, and then adding 7 to that result. There's no way of simplifying this expression further without knowing x. So algebraic expressions capture the mathematics of numbers on unknown numbers. They really help us build expressions which, once we know some more information, we can evaluate. So let's build some expressions. If Sharon is X years old today, how old was she 3 years ago? She's X years old today. So to find out how old a person is 3 years ago, you subtract 3 from their current age. Suppose you are 10 today, then 3 years ago you are 10 minus 3, 7. You'll just give me the answer directly. You'll say, I was 7 3 years ago because you knew 10. But if you didn't know that you were 10 and you were depicting it by a variable x, then to tell me how old Sharon is 3 years ago, you would have to subtract 3 from Sharon's current age. And this is all you can say about how old she was 3 years ago. Since you don't know x, x will surely appear in the expression. 2. If Sharon is x years old today, how old will she be 7 years hence? If you know your age today and you want to know how old you are 7 years later, you will add 7 to it and you will tell me the answer because you'll be able to do the addition. I keep emphasizing this, that since you don't know Sharon's age, all you know is x. To tell me how old she is 7 years hence, you know you have to add 7 to x. But you can't simplify this further because you don't know x. So her age 7 years hence will be x plus 7. Pardon my x's, curves don't seem to be meeting. If Sharon was x years old 3 years ago, how old is she today? So she was x years old 3 years ago. How old is she today? So compared to 3 years ago, she's 3 years older. So if she was x 3 years ago, she must be 3 more. So today she is x plus 3 years old. Again, I don't know how old she was 3 years ago. I only know she was x years old. So if I add 3 to it, I will know how old she is today. So this is the best I can do. If Sharon was 3 years old x years ago, how old is she today? So she was 3 years old x years ago. So you got to add x to find out how old she is today, because she has grown x years. So to what she was, if I add x, I get her age today. So 3 plus x is what she will be today if she was 3 x years ago. So let's define algebraic expressions now, a little more formally. So I'll write a large algebraic expression. So if we look at this expression, what are the variables? The variables are x and y. These are the two variables. Which are the constants? Well, the constants are those terms that do not have any variable in them. So in this case, just the 3. 3 is occurring alone. It does not have a variable in it. So 3 is a constant term. Well, before I say 3 is a constant term, I should tell you what terms are. So this entire expression consists of terms. So terms are separated by plus or minus. So how many terms do we have? This is 1 term, 2 terms, 3 terms, 4 terms, 5 terms. So there are 5 terms. We can examine each term separately, and then when you add and subtract terms, you get a large expression. Let's look at a term. Let's look at the term 4xy. So it has two variables, x and y, which are multiplied, and then the whole thing is multiplied by 4. So we call 4 the coefficient. 4 is the coefficient of the term. So whatever are the constant numbers appearing in a term which are being multiplied to the variables are called coefficients. For instance, look at this term. This term is minus 4 square x cube. So this is actually minus 16 x cube. So the coefficient is minus 16. Let's look at the term 7x. So there it's clear, the coefficient is 7. And look at the first term, 3x cube. There it's clear the coefficient was 3. And then finally we have what is an expression. An expression is the sum of terms. So we simplify expressions just like we simplify numbers. We add and subtract expressions. Remember, we don't know what x is. The best I can do is add x to x, because I know adding x and x gives me 2x. Or I can subtract x from x. I know subtracting x from x will give me 0. But I can't add x to x square. I can't say x plus x square is something. The best I can say is it is x plus x square. Without knowing x, there's no way I can improve this expression. It will stay x plus x square. What I'm driving at is different powers of x cannot be added. You can't add x cube and x5. You can't subtract x cube from x raised to 7 because you don't know what x is. The only thing you can do is add the x's, add the x squares, add the x cubes, and so on. And of course, you can add and subtract the numbers like you always did. So here, I have some constants and I have some x's. I have 4 minus x plus 2x plus 6 minus 5x. So I should group all the x's together and group all the constants together. That's the best I can do. So I can do 4 plus 6 minus x plus 2x minus 5x. I've just moved the plus 6 with the 4. So this becomes 10. And this total is how many x's? I have minus x plus 2x minus 5x. So I can do it in order. Minus x plus 2x will give me 1x left. That x minus 5x will give me minus 4x. So I'll end up with 10 minus 4x. That's the best simplification I can do. How about this one? Add 12 minus 4x and 1 minus x. So that's 12 plus 1 and minus 4x minus x. I've grouped the constant terms and I'm grouping the x's. 12 plus 1 gives me 13 and minus 4x minus x gives me minus 5x. So this can be written better as 13 minus 5x. 13 plus minus 5x can be written as 13 minus 5x. So that's the addition of these two expressions. Subtract 12 minus 4x from x plus 7. So x plus 7 minus 12 minus 4x. So x plus 7, and when I subtract and there's an expression in brackets, the minus sign distributes. So it becomes minus 12 minus minus 4x, which is plus 4x. Now I group the x's and I group the constants. So it becomes x plus 4x plus 7 minus 12. X plus 4x is just 5x and 7 minus 12 is minus 5. So it's 5x plus minus 5, which can be better written as 5x minus 4. As 5x minus 5. So that's how you simplify expressions. You just group like terms. Like terms are terms which have the same variables with the same powers. In these questions, of course, the only like terms were terms in x and constant terms, terms without a variable. Okay, here's a slightly more tedious example. So here let's look at the different like terms. So there are terms in x square, there are terms in x, and there are constant terms. So finally when I simplify this, I should actually have three terms. I should have a term in x square, a term in x, and a constant term. So let's first group all the x square terms. So that's 3x square minus x square plus 4x square and a plus 5x square. That's giving me all the x square terms. Let me also isolate all the terms in x. That's minus x plus 5x plus x minus 2x. And then let me group all the constant terms. That's 7 plus minus 8. That takes care of the constant terms. Let's work out each of these expressions. 3 minus 1 plus 4 plus 5. That's 5, 9, 12 minus 1. That's 11x square. Minus 1 plus 5 plus 1 minus 2. The minus 1 and plus 1 cancel out. So what we're left with is 5 minus 2, which is 3. So we have 3x finally. And 7 plus minus 8 is minus 1. So these are my three terms. To build up the expression, I just add them. So the final answer is 11x square plus 3x minus 1. So that's how I simplify a complicated expression. Simplify. Okay, now we have two variables and they are raised to different powers. Remember, x cube and x square can't be added or simplified further because you don't know x. Here, when you have two variables and they are raised to different powers, the only like terms are when all the powers of all the variables are the same. So for instance here, x cube y cube is one term, x square y4 is another term. These two terms are not like terms because one has x cube, one has x square. Then there's an x square y term and I see an xy square term. I see an x square term. I see an x term. Let's see if we've covered everything. Let's start grouping them. So x cube y cube, there's just 7x cube y cube. There's no other x cube y cube term. How about x square y4? There's an x square y4 plus 3x square y4. So that gives me 4x square y4. Then x square y. There's a minus x square y and 5x square y plus 5x square y. So that becomes 4x square y totally. How about xy square? There's a minus xy square and a plus y square x. But y square x is the same as xy square. You're just multiplying all three. So that's plus y square x, which is the same as xy square. So this adds to 0. Then there are x square terms. Which are the x square terms? There's just one x square. And there's an x term which is 2x. So what's my final result? It's 7x cube y cube plus 4x square y raised to 4 plus 4x square y. The xy square terms cancelled each other out. Plus x square plus 2x. And that is my final expression. Binomials, trinomials and polynomials. So polynomials are very important algebraic expressions because they are used very commonly and a lot of questions can be expressed in terms of polynomials. So what's a binomial? Well, a binomial is an algebraic expression with two terms. Bi means 2. So this is a binomial. X plus 3 or x cube plus 7 or 7 minus 8x. These are all binomial expressions. You see they have two terms. The two terms are separated by a plus or a minus. So that's a binomial. So similarly, what's a trinomial? Well, obviously a trinomial is an expression with three terms. So x cube plus 4x minus 7 is a trinomial expression. And what's a polynomial? Well, that's an algebraic expression with any number of terms. So be something like this. That's a polynomial expression. Or something like this. This is also a polynomial expression and this has multiple variables. It has 3 variables in it. So the important thing to note about polynomials is, firstly, you have variables and they are raised only to integer powers, only to positive integer powers. So for instance, x raised to half, even though that's an algebraic expression, cannot be a polynomial. We only allow positive powers or 0. So you can have x raised to 0, which is a constant one. Or you can have x or x square or x cube and so on. Only positive integer powers are allowed. And of course, you're allowed to multiply, add and subtract. No division. Polynomials, there is no division of a variable by another variable. I mean, x by 3 is allowed because this is the same as 1/3 x. You can divide by a constant, surely, but you can't divide variables. So for instance, x by y is not allowed. that would not make it a polynomial. It'd still be an algebraic expression, but it won't be a polynomial. Polynomials restrict us to just addition and subtraction of terms, and each term, the variables must be raised to positive integer powers. Positive integer powers. So for instance, 1 by x is not a polynomial because this is x raised to minus 1. And x raised to minus 1 is not raised to a positive integer. So let's look at polynomials in one variable, just x. A variable will just be x. So the constant polynomial is just a polynomial with one term, which is a constant. There is no x. So like 3 minus 13, minus 7 by 4, minus pi. All these are constant polynomials. They're just a constant number, fancy term, constant polynomial. What's a linear polynomial? So linear polynomial in one variable will only involve x and no greater power. So it will be something like 3x minus 4 or just 2x. These are polynomials which are linear. You cannot have higher powers of x, and since there's only one variable, there's just x. So for instance, 13 minus 7x is a linear polynomial. Quadratic means power 2. So you are allowed powers 2 and 1. So you can use things like x square and x. So typically x square is a quadratic polynomial, or x square plus 5, or x square minus 3x minus 17 by 2. They are allowed powers up to 2. So power 1 and 2, and of course constant terms. So these three polynomials are the ones that are most studied, the linear and the quadratic. The reason it's called linear is it comes from the word line. So when you graph these polynomials, you get a straight line. We'll see that in the functions chapter and when we study graphs. That's the reason it's called linear. Quadratic polynomials are raised to the power 2, and when you graph them, you get something called a parabola. So we just discussed polynomials, and I said that 1 by x was not a polynomial. So we broaden our definition of an algebraic expression to include such expressions, and they are called rational expressions. Why rational? Recall that a rational number was an integer divided by an integer. So a rational expression, by extension, is a polynomial divided by a polynomial. So 1 by x turns out to be a rational expression because 1 is a polynomial, it's a constant polynomial, and x is a polynomial, it's a linear polynomial. Similarly, 2x square over 3y is a rational expression, or x over 8y cubed minus 4x. These are all rational expressions. Of course, 2x is also a rational expression. It's 2x upon 1. Just like every integer was a rational number, it could be written as a upon 1. Similarly, every polynomial is certainly a rational expression. You just make the denominator 1. Recall that rational numbers a by b, but we always specified b could not be 0 because you can't divide by 0. So that similar rule has to apply here. So a rational expression is a polynomial over a polynomial, but that polynomial isn't allowed to be 0. So now we have an expression, and what do we mean by substituting values? It means we have been given the values of the variables x, y, z or whatever, and we put them into the expression and we see what answer we get. Since these x, y, z's are variables, they're basically placeholders for numbers. The minute we know the numbers, we can actually evaluate that expression by putting in those numbers and then just following the laws of arithmetic. What is the value of the expression xy minus 2z square plus 1 upon x plus 2? When x is something, y is something, z is something. So xy will be 2 into minus 4 minus 2z square, that will be 2 into minus 3 the whole square, plus 1 over x plus 2, that's 1 over 2 plus 2. All I've done is plugged in the values of the numbers. So when x is 2, wherever x occurs in the expression, I put in 2. Y is minus 4. So wherever y occurs in the expression, I put in minus 4. And of course, I'm very careful about my minus signs. Now 2z square, that expression is ambiguous. Is it 2z the whole squared, or is it z square multiplied by 2? Well, of course, it's z square multiplied by 2 because exponents have a higher priority than multiplication. So 2z square means z square and then multiply times 2. If I wanted 2z the whole square, I'd have to put brackets. This means multiply, then power of 2. That's the convention. So you notice that 2z square has been written as minus 3 the whole square and then multiplied by 2. Now let's simplify this whole expression. 2 into minus 4 is minus 8. Minus 2 into 9, minus 3 square is 9, plus 1 by 4, which will end up being minus 8 minus 18 plus 1 by 4, which is minus 26 plus 1/4, which is minus 25 and 3/4. So that's the step-by-step evaluation of the expression. Each term must be evaluated and then the terms should be added and subtracted. Next question, when is this expression undefined? What do they mean by undefined? They mean, are there any particular values of the variables where you cannot evaluate? Well, of course you can evaluate multiplication, raising to a power, adding, subtracting for any values of variables, because any number can be raised to any power and any number can be multiplied by any number. What's the only issue here? The issue is in division. I cannot divide by 0. So what's the term that causes division? 1 by x plus 2. So 1 by x plus 2 will not be evaluated if x is minus 2. If x was minus 2, then I would end up getting 1 by minus 2 plus 2, which is 1 by 0, which is a complete no-no. So the expression is not defined when x is minus 2. I cannot evaluate. So the complete form of this expression is that x, y, z are variables, but x must not be allowed to be minus 2. So that's what we mean by when is the expression undefined. It is those values of the variables which are not permitted because they lead to an undefined operation. In this case, x equal to minus 2 led to us dividing by 0, which isn't permitted.